This interactive figure gives us a nice visual on how the pull of the moon, the gravitational pull of the moon, distorts the water on Earth, causing the tides. It causes a tidal bulge along the line between the Earth and the moon, and then as we rotate, as the Earth is rotating underneath it, we experience high tides and low tides. So if we start this moving also, notice there's also a line representing the force of the sun. While the sun is very large because of its large distance from the Earth, the effect of the sun's tide is not quite as dramatic as the moon. The moon plays the big role here. So let's start this moving. And so you see the Earth rotating underneath the bulge, and notice how the bulge is changing shape. Actually, it's sort of nice to notice that as the line of the sun and the moon sort of change orientation relative to each other, you should notice that the bulge either increases or decreases. When they're all lined up, the bulge gets very large. When they're at right angles to each other, the bulge is not as noticeable. Keep in mind that this is going to happen at different times of the year. So right here, they're totally lined up. The high tide is going to be very high. The low tide is going to be very low. This is called spring tides. When the sun is at a right angle to the line of the Earth and the moon, the bulge actually is the opposite. That is, there's not as much of a difference between the high tide and the low tide, and we call those neap tides.